Hello, my cherished viewers out there. I welcome you once again to yet another session on my YouTube channel, Rediscover Your Touch. I'll actually be taking you through a drilling example or a couple of drilling examples under the same Theorem 1, and I'll actually be helping you guys to understand some core aspects as to why we have some of our workouts to be so. Over here, I'll urge each and every one of you guys out there to pay rapt attention and focus on these critical aspects of the examples that we'll be tackling. And in that sense, we'll actually be making it to the core. But prior to our commencement, I'll urge each and every one of you out there to do it a chance to subscribe to my YouTube channel, to share, and also to like my videos as well in order to bless others too. Alright, so I trust we can commence. In example 3, we have this diagram that is quadrilateral PQRO, and we are having an angle form at O, and we are being tasked with finding angle PQR. So this is angle PQR. Okay, sometimes most students hate represented angles in 3 forms. Okay, so in order to address that issue, we could say that we could represent it by representing it with an alphabet, or specifically a variable. Okay, so we could simply say let angle PQR equals x degrees, and then wherever we see PQR, we could substitute it with x, and then we'll go along with our calculations. Easy does it. Okay, so we are still on Theorem 1, like I stated, and we'll actually be deliberating on how well we could handle this issue. If you could compare this diagram to our standard diagram on Theorem 1, typically representing Theorem 1, you realize that in order to fall into that theorem, or in order to attend to the demand of that theorem, the arcs must be in the same direction. So if you realize, the angle forming at the circumference were having similar shape. They were both facing upwards. Or be it so, if they are facing downwards, then it ought to be like this. I trust you get this. So in the instances where you have the arcs facing each other, it will never supply to the demand of the law or to the theorem. And in that sense, you will be making a blatant error. And I urge you guys to pay due attention to this deliberation so that you wouldn't be committing such errors. And in that sense, I trust we could commence. So like I stated, we have to make sure that the arcs are facing the same direction. So it means I'm not going to connect 100 to x. That would be a fatal error. But rather, I'm going to find the reflex angle here and rather connect it to x, in the sense that both arcs are facing the same direction. I trust to get this tip. Alright, so angles formed at a point that is specifically at the center sums up to give you what? 360. So it means I'm going to have, supposedly, if my reflex angle is, let's say, y, I'm going to have y degrees plus 100 degrees is equal to 360 degrees. And then my y is equal to 360 degrees minus 100 degrees, which gives me 260 degrees. So that's 260 degrees. 260 degrees. So I could state it here, 260 degrees. Now we can finally connect 260 degrees to the angle formed at the circumference. And mind you, per our previous example, when we are being provided with the angle at the center and tasked with finding the angle at the circumference, we are actually going to divide, right? So we are going to have our x to be 260 divided by 2. And in that sense, we could use our long division. So we have it this way. 2 goes into itself once, 2. We add the next number. 2 goes into 6, 3. And then we just add 0. So we are going to have 130 degrees as our angle PQR. That is representing or replacing X with PQR. I trust you get this. So when you are able to dodge the error, you actually get your answer right. So always note that the arc should be facing similar direction and not opposite direction. I trust you get this. Alright, moving on to example 4. Making use of example 4, we are being asked to find POS. POS. That means, like I stated in example 3, we are not going to find this angle. No. Why? Because they are facing each other, or in other words, they are facing opposite directions. But rather, we are going to make use of the reflex angle here. So this is correct, and not the angle facing it. So you realize that the angle at the circumference is facing the bottom, and the angle at the center is also facing the bottom. And that is how it actually goes, per the demand of the structural diagrammatic display of Theorem 1. Okay, so we'll actually set sail from there. So you realize that this is a easy task, or actually an easy task. That is, we already have an angle at the circumference, and we are being charged with finding the angle at the center. But initially, I've tackled the issue about having our center to be the reflex angle and not the obtuse angle. And in that sense, we are going to have POX. We could actually represent it with an alphabet or a variable. So let's say I use K. So I'm going to have, as far as I'm having my angle at the circumference, I'm going to have my angle at the center to be twice whichever angle it is at the circumference. So I'm going to have my K, that is solution. My K degrees is equal to 2 times 104 degrees. K is equal to 2 times 104 degrees. So we multiply 104 times 2. So 248, 0, 212. So we have 208 degrees. But our K is also what? Angle POS. So therefore, angle POS gives us what? 208 degrees. Our angle POS translates to give us what? 208 degrees. So this is it about a little bit complex aspect of an example we could have on Theorem 1. So like I said, the critical message I'm posing out there is that you should always be a contractor, or in other words, be technical about the direction of the arc pertaining to Theorem 1. Else, we'll be committing blunder errors, assuming that we rather be getting the answer right. That isn't right at all. So in order to avoid such troubles, you should always be cautious about the direction of the arcs. And in that sense, you'll be on the right track, and you'll be aligning your responses or your method on Theorem 1, and you will never be having biased answers. So I'll actually be drawing curtains on today's lesson concerning further examples on Theorem 1 concerning plane geometry 2 and specifically circle theorem. So I trust you find this knowledge more elaborative, and I'll be doing my best to also address other issues concerning Theorem 2 and its related examples. Until then, I'll actually be saying a goodbye to all my supportive fans out there, and I'll remind you to actually subscribe to my YouTube channel, to like this video and share among your colleagues as well, so that we'll all be impacting lives to rediscover our touch in general. Kudos to you all, and bye.